All right, quick review. I'm going to go backwards as my brain likes to work these. So I'm going to start over here on the right with 3 and 4. So I'm going to swish and flick. 7 to the n equals m. 5 to the 2 equals 25. Now in these, you're going to write log every time. And then I start with my base, 3, and I actually do this, 3 to the x equals g. Here's my base, m to the n equals p. Okay? And again, that's just the way my brain has to do it. All right, so in this lesson, we're going to be putting these into the calculator. So y equals 2 to the x. This is exponential function. So we go to our calculator, clear out what we have here. Y equals 2 to the power of x. Okay, so we've done this before. So go to the table, and we'll get some points. Again, my asymptote is the x-axis. So we're looking for 0, 1, 1, 2, 2, 4. Three, 8. And it's going to look like this. 0, 1, 2, 1, 2, 2, 4, and 3, 8. Don't really need to worry about those. Those are getting tiny. Okay. Now the inverse of y equals 2 to the x, remember, all you do for inverses is switch the y and the x. So this is going to be x, and this is going to be y. Now we can't put that on our calculator, but remember, if we have this, we can just flip it. So this is going to be 8, 3, 2, 4, 1, 2, 0, 1. So I put these in. Here's 1, 0, 2, 1, 4, 2, and 8, 3. So that is actually going to look like this when we graph it. So the border here is right there. All right, it says now rewrite the inverse as a logarithm. So we're going to rewrite this one, notice it's in red, as a logarithm. So again, 2 to the y, so 2 to the y equals x. And here we have the blue one here, 2 to the x equals y. So that means this means that an exponential function and its logarithmic function are inverses. Again, the x and the y switch. Okay, so we can graph logs by thinking of them as exponential functions. But we're also going to show you how to use the calculator to graph these very easily. So when you're doing this, when you go to y equals, okay, you're actually going to go to the math key, and you're going to go up a couple, might be 2 or 3. You can go down, but it's quicker to go up. And you're going to go to this log base. And you can just put this in. So if you notice, we have log base 3, and you arrow over to the parentheses, and you just put the x right here. And we can graph that. And we can get a table. Now think about it. For exponentials, our asymptote was a horizontal line. Well, with x and y switching, now our asymptote is going to be a vertical line. X equals instead of y equals. Now you'll notice here you're going to get a lot of decimals, not a lot of whole numbers to really do. So you just work with what you can, right? So for this one, you know, you're going to get 1, 0, 3, 1, and 9, 2. And that's all you got. So 1, 0 right here, 3, 1 right there, 9, 2 right there. And again, our asymptote is going to be a vertical line this time, and so this is going to come this way and just ride on down this line. Okay, exponential form of this, remember this is y, so 3 to the y equals x. Now the domain and range, being that x and y, remember domain is your x values, range is your y values, they switch. So before our domain was always negative to positive infinity, this time the range is going to be negative to positive infinity because it's going up and down forever. Now the domain left to right, it's going right forever towards positive, but it's not going past 0. And we use a parentheses because it's not hitting 0 or crossing it. All right, and our x-intercept is what we're looking for, is on our chart right here, 1, 0. And remember, this time we say x equals because it's a vertical line. All right, same thing here. When we go back to our y equals, we can actually just go here and change this. I'm going to change that to 0.5 and graph that. Okay, notice it's going the other direction because it's 1/2. It's a number fraction, less than 1. So here we go. So some points here are 1, 0, 2, -1, 4, -2, and 8, -3. So 1, 0, there's our x-intercept, 2, -1, 4, -2, sorry, this printed goofy, and 8, -3. So again, this is going to have the asymptote on the axis, 0, and we're just going to draw it and ride up the line like so. Again here, this is y, so 1/2 to the y equals x. Range, up and down forever. Domain, 0 to positive infinity. X-intercept, again at 1, 0, and the asymptote again at x equals 0. How's the information above compared to that of exponential functions? Pretty much switching things. Okay, x for y. We have an x equals asymptote instead of y equals. The x-intercept instead of the y-intercept. Domain and range are kind of flipping their values. All right, transformations. Similar to what we did with exponentials, okay? A out here. So we have horizontally stretched if greater than 1, compressed less than 1, and reflects across the x-axis, not the y-axis, if it's negative. H, again, moves it left and right. This is that inside lies again. So opposite what we think. Minus is right, plus is left. And then K, up and down just like before, like we thought. Okay? So since logarithms are inverses of exponentials, everything switches. So like we talked about, for exponentials, domain is always negative positive infinity. This time it's range. The range before use K. The domain this time is going to use H. Okay. Horizontal line for the asymptote. Vertical line for the asymptote. So everything just switched. So here we go. Now, remember, just like before, you can use your calculator And if you want to see these in action, you can graph log 2 of x as your parent function in 1, and then put this one in 2, and you'll see exactly what happens. So again, inside lies, so it's going to move left 3, it's going to move down 2. The range is always negative to positive infinity. Okay? Now the domain and asymptote, remember, the domain is h, this number here, to infinity. Okay? So in this case, whoops, wrong way, h is 3. Or negative 3. So negative 3 to positive infinity. And that is also going to be my asymptote. Okay? On the next one. This one is going to move it right 1, up 5. The negative is going to flip it. And the 2, being greater than 1, is going to stretch it. So again, the range does not change, negative to positive infinity. We're looking at h, so 1 to positive infinity, and x equals 1. All right, so here we go. So notice there is no left and right movement on this one. This negative 2 is going to move it down 2. The 1/3 is going to compress it. And that's all we got for transformations. So the range, again, does not change, negative positive infinity. The domain is going to be 0, because this is really just x minus 0 to positive infinity. And then we're back to x equals 0 for our asymptote. All right. Now, just notice here, the setup here. Notice that x minus 2 is not in parentheses. This is log 2 of x minus 2, which means it's going to go down 2. That is very different than if you had this. That would mean it would move right 2. So just pay attention, slight distinction there. So I put this in my calculator using log base. I have 1, negative 2. I have 2, negative 1, 4, 0, 8, 1. Okay, so 1, negative 2, 2, negative 1, 4, 0, my y-intercept, my x-intercept, and 8, 1. So, again, I have no parentheses, I have no h, so therefore, my asymptote is back to the x-axis, the y-axis, sorry, inverting it myself. And then I'm just going to draw this and then run down that line, like so. So the range does not change. The domain is 0 to positive infinity. The x-intercept is 4, 0. And the asymptote is h again, x equals 0. Okay, here we go. I'm going to put this one in. Now, I want to show you something interesting about the calculator. It's kind of a fault of the calculator. So on this one, we're going to go math, and we're going to go log base again, and we're going to put log base 3, and we're going to put x plus 1, come outside, and put minus 2. Not plus, minus 2. Now watch what happens when I graph it. It looks like it just kind of stops in midair. You need to continue it all the way down the line. The calculator just cannot process with, the screen it has and the computer processing power. It just can't continue it. Don't draw this, please. Do not draw this. Continue the graph. Okay? So, what are some points we have here? So we have 0, negative 2. We have 2, negative 1. And we have 8, 0. So 0, negative 2. 2, negative 1, and 8, 0. Again, there's my x-intercept right there. All right. Again, right here, inside lies. So negative 1 is my asymptote. So when I draw this, it's going to connect the dots and then just ride down that line. So the range does not change, negative to positive infinity. The domain is at negative 1 to positive infinity. And the asymptote is at x equals line, a vertical line of x equals negative 1. Remember, the calculator does this and just stops right there. Don't do that. Continue all the way down. All right, notice this one can be a little bit different. Now, on something like this, when you have something in front of the log, before you hit the log base, all right, you have to enter that. So this time it's negative. If it was negative 2 out there, like on the previous one, we would do that. So make sure you put that in first. There's my negative. Now I go to math, log base, and I have base of 2, x minus 3, which means it's moving right 3. Move outside the parentheses, plus 1, which means it's moving up 1. That should look like that. Now again, notice how I can't process all the way up. Go all the way up with this. And if you looked at this one on the table, you really don't have a lot here. You got 4, 1. You have 5, 0. I guess you have one more. We got 7, negative 1. I missed that. And off the chart a little bit, we have 11, negative 2. So 4, 1, right here. 5, 0. There's my x-intercept. 7, negative 1. And 11, negative 2, like right there. Again, inside lies. So my asymptote is going to be at positive 3. There's my border. So I just come along here, connect the dots, and then ride all the way up. Remember, the calculator stops right there. Don't do that. Continue your graph. Be smarter than the calculator. The range is, again, negative to positive infinity. It's going up and down forever. The domain is at h, positive 3, and then going towards positive infinity. And that h comes down here again for x equals 3. And there you have it.